This video, we go over an inventory model, the single period model. It's also called the Newsboy problem. Based on the story behind it, is that if you were a kid who sold newspapers back in the 20s, you would go buy the newspapers at the newspaper store, then you would lug those, carry those down to a street corner, and then you would sell newspapers. And if you didn't take enough and you ran out and it was a busy day, busy news day, then you lost revenue. You lost the opportunity to sell more newspapers. So you want to make sure you have enough newspapers so you don't run out. However, if you take too many down and it's a slow news day, and you at the end of the day and you still haven't sold your newspapers, well, what do you do with those? You can't sell them tomorrow, so the salvage value, that cost is generally a lot less than what you purchased it for. So you might be able to do something with those. And so in today's world, if we've got items that you really get one shot of determining how much you need to order, and it's you don't have time to replenish, then the Newsboy problem is appropriate. So certainly items that expire, food products is a very common one. Styles, if for very seasonal items, is another one where you kind of get one shot at it. But also in revenue management systems like the number of selling seats on an airline that's about ready to take off. Once that airplane is taken off, you can't sell any more seats for that particular plane. So the Newsboy problem is a great way, and the other thing about it is that it uses historical demand data to help in these cost drivers to come up with what the optimal service level should be. So rather than saying that I want to have a service level of 100%, what this does is based on these cost drivers, it tells you what the optimal service level should be. So the problem in Excel that we're doing is that it's an example from page 265 in the book, and they're selling a fashion swimsuit. It's a swimsuit, and what the item cost, the store, the retailer, is $40, and they want to sell it for $60. But at the end of summer, they do a big sale and sell anything that they haven't sold during the summer. And you can see that the price is slashed from $60 to $30, which is less than what the item originally cost. So you don't want to have too many, but you want to have enough so that you don't run out. So these are the three cost drivers that dictate something called the cost of being C of S and C of U. And different books use different terminologies, but in this case, C of S is the cost of overestimating demand. It's the cost of being long. It's what your cost is if you have too much. So you can see that how it's calculated is that it's the difference of what you pay for it and what you can sell it for later. So if they're long, if they have too many, then you can see what the unit cost is. They're out for $10 for every one they have long. If you couldn't sell this, just think about this. If you couldn't sell these swimsuits and you had to throw them away, you could see that this becomes real expensive. The other one is the cost of underestimating, or the cost of being short. If you run out, what is the unit cost to you? Well, we're going to lose $20 for every unit that we don't have enough of, because we want to sell them for $60. We cost us $40, so what we're out of pocket is $20 for every one that we don't have enough. So from these two numbers, we calculate these: the C of S, which is the cost of overestimating; C of U, the cost of underestimating; or this is the cost of being long, the cost of being short. Once you have those, then you can calculate your service level, and what that is C of U all over the sum of CU and CS. So what's cool about this is that this service level is what you should try to achieve. In this case, you shouldn't try to achieve a service level of 90, 95, 99. You should try to achieve a service level of 67. That will maximize your expected profit. And let's just look at these drivers numbers and understand how that impacts this. I'll say for most things, if you buy it for $40, you're probably not going to sell it for 40. You're probably going to sell it for like 100, 120 or something like that. So let's put this to maybe more realistic. If we buy something for 40, we're going to sell it for much more than that. And you can see in that case, you should have a service level much higher because the cost of running out, the cost of being short is much higher. So you can play with these different numbers like I did before. If you cannot salvage this at all, if you're truly out of pocket, if you have extra, then you can see what the service level is you should try to achieve is very small. You shouldn't try to have a high service level. If anything left over, you lose. And the cost of you is large relative to the selling price. There's plenty of systems out there where 100% service level doesn't make sense from an economic standpoint. There are some places that compete on high service. That's how they choose, is to have high service. But there's some things that where service is not that important. There's other things that are more important. There's certainly good restaurants out there where people will wait in line, and if you run out of food, that you run out of food. But people will still be there. They're not really there because of the service. They're there because it's really good food. Okay, so that's what the first part of this does, is give you the economic service level, the optimal service level. Now, after you have that, then you can apply that to different demand patterns. So if your demand pattern is normally distributed, and you can use histograms to identify that, but if your demand is centered at 500 with a standard deviation of 50, then what your optimal order quantity should be is you put in your service level as your first argument, then you put in your mean and your standard deviation, and that tells you that this is how many swimsuits you should buy. We think that the demand for the season is 500 swimsuits, but it's not a constant. There's variability around that. And so what you should do to achieve a 67% service level is buy more than the average. If you would just buy the average, if you would just buy 500, your service level would be 50%. Half the time you would have enough, half the time you wouldn't. The other one, and this is probably the one you'll use most often, but if your demand is noisier, and what that means, it's just uniform. So if you read the book, a uniform distribution is just everything is equally likely between these two numbers. So it's not we don't have a larger point in the middle like a normal distribution that's bell-shaped. A uniform means it's shaped like a rectangle. Everything is equally likely between these two numbers. So in that case, if that's true, how you determine the optimal order quantity is you start here, and then you add the service level multiplied by the difference of these two. It's your minimum plus your service level times the difference of these two. And again, the formulas are already ready. It's a template set up. Actually, I just reproduced the template in the book with a slightly different terminology on things. So that's the Newsboy problem. Thanks.